Class? Good afternoon. You guys do better than that. Good afternoon, class. Good job. Okay, so again, we are going to continue more on experiments with chemistry. We actually has 4 different vegetables or fruits?
Yes.
Okay. Everybody has the goggles on?
Yes.
Okay, good. Okay. So I want you to place a different vegetable into each test tube. So one vegetable for each test tube. Just drop it right in. And you're going to observe what happens. Oh, okay.
Because there's a bunch of bubbles right here.
Yeah. So they have that reaction going very, very fast. Which one do you guys see has the least amount of reaction?
Red apple.
The red apple? Everybody
Yeah,
agree?
that's a lot. It's going to take more time.
Yeah, it's going to take a lot of time for that breaks down. So this is an example of a chemical chain that occurs in our body. Example for during digestion. Food is broken down into nutrients by enzymes. Yeah, all of it.
This, right?
There's going to be different parts to it, so you guys will have time to take turns to do different things. Okay, what happened? Michelle.
It went to the bottom of the surface.
Hold on a second. Hey guys, you guys have to be quiet. Michelle, can you repeat that?
The water went down to the bottom of the cup because it had more density.
Good job. The reason why the water went below the oil because the water had more density than the oil. So we oppositely we can say, hey, because the oil was less dense than the water. So this separated. Okay, now, our volunteers are going to come by. I'm going to put a couple of drops of food coloring into your cup. No. No, you can add like 4 or 5 drops. 4 or 5 drops? Yeah. Into the cup.
Why did it go to one side? Why did it just go to the other side?
Remember, don't do anything. You're just observing right now. Austin, did you get pick up the cup? Okay, now you can pop or push each drop to the mixture. So you use your stir, and you can see if you can pop the different drops of the food color. Push it down.
Wait, I got an idea.
So one person in your group take stir. You guys have to stir, right? Where'd the stir go? Oh, you want to try and see if you can pop, push it down. The food coloring only change the color of the water. And the oil is still less dense than the water. It still did not mix. Now you guys can try and stir it together. I want you guys to take somebody in your group, stir, see if you can stir the mixture. Keep stir the mixture. Is the oil and the water mixing together?
No.
No, it's still not changing.
Is that why they say oil and water don't mix?
Well, it doesn't mix, that's not why they say that. It has to do more with being polar, not. Okay, now, each table got a cork. Could you put the cork inside the cup and see what happens?
No, wait, what?
No, just a cork. Not a cork like just a cork. And you want to take turns. Now try and push the cork down with your stirrer.
Wait, you just have to use the gun.
Can you push the cork down?
Barely.
No.
Well, actually, let me repeat it. Can I change this sentence? Can you keep the cork down at the bottom?
Yes.
The cork is less dense than the oil in the water. That's why it'll keep floating. Take the Lego and put it inside the cup.
It's going down.
The density of the Lego is more than the oil. That's why it sinks right below the oil. However, the density of the Lego is less than the water, and that's why it floats. So you all should see that your Lego is in between the water and the oil. All right. Everybody has a cup with vinegar? Yes? Everybody has a graduated cylinder with water?
Yes.
Everybody has baking soda?
Yes.
Everybody has raisins?
Yes.
And everybody has, well, you don't need to stir. Just see them dancing with us. Okay, first thing you do, you're going to pour the water into the beaker.
Cup.
I'm sorry, yes, the cup. Pour the water into the cup. I switched it so you'll be able to see the raisins better. No. The water into the cup.
This is the water.
Well, that's not a beaker, that's a graduated cylinder. I changed it, I altered it.
Or do you want to take turns?
Yes, do.
Okay, did everybody do that?
Yeah.
Your cup should be on the napkin.
Now vinegar what you do.
This is why they say
Okay,
raise you can pour.
next instruction. You want to drop in the raisins into the cups.
By one by one.
You just take them and put them in.
Drop the raisins into the cup.
Now, what do the raisins look like? They're not moving, right?
Grapes.
Just stay there, right?
What?
Oh, you have to make it slow.
Okay, now you need to clear everything else off the cup, off the napkin other than the cup.
And baking soda.
Yeah, the baking soda should be in somebody's hand.
Oh, that's bad then, right?
Okay, you guys are waiting patiently, right?
Yes.
Okay. Now, it says add a heaping teaspoon of baking soda to the cup, but all you have to do is just put the whole cup into it and watch what happens. Yes. Put the whole cup into it. You gotta observe and see what happens.
Oh, I see.
What are the raisins doing?
They're breaking apart. They're breaking
Oh,
apart.
no. A
They're
little bit apart from the
They're
apart.
juggling back and forth.
They're going up and down, right?
Mexican jumping.
They're moving. So before the raisins weren't moving at all, right? They're just standing still. So that is one form of dancing. When you jump around, it's called a mosh pit.
Ooh.
I knew it!
And yes, when you had the vinegar and the baking soda, when they reacted together, they made the gas. The gas collected on the raisins, and that's what made it float up. And yes, once the gas reached the air or the surface, it let go of the raisins, and that's why the raisins go back down. So that's why it appeared to be dancing. So the bubbles are collecting on the raisins and making them move. Very good explanation. Kernels?
Yes.
And every table has effervescent tablets?
Yes.
Okay.
No, this is
So you want to take your cup of kernels and put them into the water. You want to put the whole cup into the water.
Some people some of them.
Do the kernels, yes, Michelle. They sink. The kernels are more dense than the water. That's why they sink. If it was less in the water, it would float. Now you're going to take the effervescent tablets and drop them into the cup. So you want to use both.
Are we supposed to open it?
Yes.
Do or do not?
Tear it open.
Use both.
Give it a big break.
You're going to open the packet and then put both tablets into the water.
One by one?
You can do one by one at the same time. And observe what happens. Hold on. Want to give it time for it to happen.
I can't see it.
Then you're supposed to put it in.
You put it in the water bottle. Typically you put it in. Want to take a little time so you can see if what happens.
They're dancing up.
So now you can take your other cup and put them side by side and observe the differences. What differences do you see?
This is salt, right?
Ethan, yes, Ethan, what'd you say?
I just the reason
Oh, you were saying. Caleb, what did you say? Okay, Caleb said that the kernels have less density than the raisins. What else do you guys think could have affected your results? Sandra.
The amount of tablets or baking soda you put in.
Yeah, actually the material itself could impact what you saw. That would be something else you could do. You can try using the tablets with the raisins as well and see if you get the same results. Or try putting the baking soda with the vinegar and see if the kernels do the same thing. Yes,
If you
Michelle?
change the variable, would it be like, if you use the same materials that you use for the kernels and the same variables that you use for the raisins, both of them are the same, would they have a different impact or would it be the same?
It could. That's the whole part of science. We hypothesize what we think might happen, then we go ahead and we do it. I don't want to ruin it because this is a simple experiment you can do at home. I don't want to tell you, oh, this is exactly what would happen. But you can go home and try the same experiment. Yes, what?
If you notice, this has more with the bottom is darker and it has more of the baking soda on the bottom.
Yeah.
And this one has that less, and it's like just a little coating, and it's lighter.
What's like this cup itself?
No,
Oh, the amount of stuff at the bottom? Gotcha. Well, that's because it's two different substances. Okay, we can go talk about this for a long time. We want to go ahead and get started with the next experiment. You're going to lift the edge of the balloon so that the baking soda falls into the bottle, okay? We're going to have a countdown. You can put your hand on the balloon, but don't do anything with it yet. So after I count to 1, you're going to lift the end of the balloon. Okay, so 3, 2, 1, go. Somebody has a hole in it.
Is this like helium?
No, it's not helium. It's just the reaction of the baking soda and vinegar creating a gas. Alright, so see.
Oh,
It's gonna blow down.
it's not gonna pop.
No, it won't pop.
Or it won't
It's
pop.
over here. It's got a hole in it.
What if it's gonna float in the air?
That's why you have to make
Not
the...
Mr. Reno,
Yeah.
can we tire it?
Sure. If you want to, you can take off your balloon and tie it off. If you want to keep
I
it.
have no idea how to do that.
So what happened? What did we just do? Yeah, Sandra.
Was it vinegar inside?
Vinegar was in the bottom,
Okay.
and baking soda inside the balloon.
Did the vinegar and the baking soda combine for a chemical reaction and that made a gas which filled up the balloon?
Good job. Did everybody hear what Sandra said? Ryan, what did Sandra just say? You don't know because you were talking.
Andrew was
It doesn't matter. Andrew doesn't control you. Sandra, can you repeat what you just said again, please?
The vinegar and the baking soda in the bottle combined for a chemical reaction which made a gas that filled up the balloon.
Exactly. That's exactly what happened. Okay. Any questions? Yes, Ron.
Are balloons made of helium?
Yeah. Okay. So when you get a balloon from like a street vendor, that is filled with helium. That's what makes it rise up. These balloons are just filled with H2O gas. That's it. Because the reaction from the vinegar and baking soda, it created H2O gas. You also got salt that was formed, but we won't go into detail about that. But the reason what you have inside the balloon is H2O gas. Okay. So, if you want to keep your balloon, you want to tie it off, but we're going to come by and pick up the bottles. If you do not want your balloon, then we're going to pick up both.